All right, welcome back to the architecture track. I hope you've been enjoying the conference so far. Next up, we have the API Gateway How-To, and it is my pleasure to introduce two of my fellow team members, Alberto, Ríos, and Shruti. They will be presenting the API Gateway How-To, so take it away, Alberto and Shruti.
Thank you very much, Craig. Hello, everyone. Thank you very much, all of you, for coming over to our presentation today on API Gateway Patterns. Craig, Shruti, and I are part of the Spring Cloud commercial team, and our job is to help improve the experience of Spring on different platforms. Over the past couple of years, we have been focusing our efforts on creating a variety of products around API gateways and API management tools using out of the Spring project. And this is why we are here. We wanted to share with you some of the frequently seen patterns in the industry that we kind of wish we knew when we were working on other projects. So this will hopefully give you some inspiration on how to design and implement an API gateway for your own use case. We will also touch on the differences between an API gateway and a service mesh, and how can you divide the responsibilities between the two. So let's start. You have probably seen this slide before. It means that whatever we say should not be added to any contract because it may change, but we're not here to sell anything today, so we should be fine. And with that out of the way, let's start by briefly defining what an API gateway is. So an API gateway is essentially a reverse proxy that processes incoming requests and sends responses back. When we have one, we are going to have a single entry point between clients and services, making all this client experience much more simple. API gateways are one of the most common patterns within the microservices architecture because they provide one elegant way of reducing the amount of duplication and variation in handling cross-cutting concerns. They allow you to monitor, deliver high availability, secure APIs at a single point, leaving your application code much cleaner. Meaning that when you adopt this pattern, your application code is likely going to be reduced, which is typically a good thing, right? So gateways can vastly differ from each other depending on the part of your application is trying to simplify. Some gateways aim to understand usage, metrics, or adding security, while other gateways are just a facade to hide complexity from our users. So let's talk now about what of these type of gateways are. Shruti?
All right. So this is a quick overview at the different forms of API gateways we've grouped various roles a gateway can play into all of these different types. And these are the patterns that we'll be covering as part of this talk. So let's get into the first of these, API management for existing APIs. So if you are publishing a set of APIs, whether they are for internal customers or for external customers, you usually have a host of things to worry about. And it can include any of these following concerns. How are the customers using the APIs or accessing the APIs? Are there enough sufficient and correct security mechanisms in place to restrict access and make sure only the right people are accessing the API? What should happen if parts of the system are down or overloaded or are in an erroneous state? And if needed, and if your organization has a need for monetization, how can I monetize this catalog of APIs? The concerns listed here and many, many more are often shared in many APIs that are published out there and where they have these host of concerns to solve. So even if your API really only cares about the core business logic of whatever subdomain that you are working under, it will also need to somehow handle all of these responsibilities and solve these concerns in order to provide a great user experience or good experience to clients. And these responsibilities might include monitoring and collecting usage metrics, authorization, monitoring and revoking API access, implementing security flows, rate limiting, error handling, monetization, among a few. And as you can see here, none of these really relate to the core business logic, but you need to have a collection of these features in order to make a functional, production-ready API. And when the reality is that you have to solve these concerns while not really caring about it, as it relates to core business subdomain, it can get quite messy. Instead of having a very succinct design of individual APIs, you might end up with a very heavy design where individual services have to all solve these problems. So here is where you can introduce an overarching gateway for API management to solve all of these cross-cutting concerns. You can move these cross-cutting concerns and responsibilities from each individual service to an overarching gateway. So this removes duplicity and ensures that all of the important concerns are all succinctly solved in one place. And any future changes that you may want to implement. Maybe in future you want to change how error handling is done, or the kinds of error handling is done, or you want to collect more metrics. All of those changes need to happen in this one layer, while each of your individual services only need to continue caring about their subdomain. So a huge benefit of this pattern is that API managers, or people who manage the API, have a high ability to control governance policies. They are able to control and manage security flows, grant and revoke API access, understand very granular usage of their APIs. And this granular usage also has an added benefit of giving organizations opportunities to monetize their API accordingly. Additionally, this pattern also takes all of your APIs and puts them in a neat package and builds a catalog of APIs that makes it available to users. So that was the first one. Let's go to the second pattern, which is ingresses for APIs and services. So an API management focused gateway is useful for collecting cross-cutting concerns. But what happens when you start thinking about and worrying about managing all of the traffic entering your cluster of applications? If your need is to manage directing traffic, entering your cluster of applications to different environments, handling throttling, rate limiting, load balancing, or even high availability, what can you really apply in this case? So here is where an ingress type gateway for traffic management is quite helpful. It will allow you a granular control of your overall traffic entering your cluster. And for traffic management, you can make the gateway receive all of the incoming traffic and forward it to various underlying services. This gateway can be aware of each service and its multiple instances and manage the traffic with whatever your chosen strategy is. And for example, you might want to apply a ratio or a percentage of how the load should be distributed between the various instances. And this kind of method can be useful for testing out canary deployments, staged rollouts, A/B testing, etc. And with this, you can also receive metrics on your traffic and how it's doing, so it can help inform future manual or auto-scaling decisions that you might want to take. Secondly, ingress management and traffic management can also mean handling sudden changes in traffic volume. Surges can put a lot of pressure on your applications and often endanger the health or uptime of the underlying services. With an ingress type gateway, you can apply global rate limits for your overall traffic or local rate limits for specific sets of services and routes so that the surge is prevented. Along with rate limiting, where your requests get rejected after hitting a set rate, you can also apply throttling to slow down and spread out your incoming requests to make the traffic more consistent. This is a use case for showing how complex route rules can also help be implemented using Ingress Gateway. So you can apply complex route rules that dictate how to manage incoming traffic. A use case that we see here is for sharing API access to the same internal resource across different parts of the organization. So in this use case, the agent line of business is externally facing, but wants to access the fraud line of business's internal services. But both line of businesses use different authentication mechanisms. The agent line of business has an OIDC mechanism, while the fraud uses internal client certificates. So with the help of a gateway to manage respective traffic, you can let the gateway manage authentication and redirections while giving the users of the agent line of business's application access to the fraud line of business's backend services. So in summary, ingress for traffic management can perform a lot of diverse roles as we went through. You can also deploy multiple gateways to manage global level traffic or local domain level traffic to achieve these use cases.
Okay, so let's talk about application modernization now, because a lot of people are moving towards microservices. That's not new, but how do you approach that migration? Big bang refactors typically don't work. At least I have done a few, and it is rarely the best approach. One way to tackle this problem is by applying the strangling the monolith pattern. We start by having everything in one monolith, as we can see over here. And then the first thing that typically you would do is just add a gateway on top. And that gateway is not going to do anything fancy. It's not going to, there can be a raw, vanilla, Spring Cloud gateway, just rerouting every single call from every client to the monolith. We don't do anything else, just reroute, because now we can move parts without any risk, right? So less riskier, we just do one thing at a time. Then, while we are adding that gateway, we need to start identifying what the bounded context our monolith has, or what can be extracted and simplified, basically. You cannot really find anything. What's the easiest thing we can untangle and modernize in a different way? Then, when we choose one, for example, the products, what's the easiest one to extract and rewrite, we are going to now change the route to go from the monolith to only the products service. And this is good because this is just applying basic rules. You don't need to do anything fancy, just very vanilla, super easy to implement using any API gateway. And this is kind of great because now just by rerouting, you can test separately things. You can test the new products microservice while the other one is still there in the monolith, right? You can decide now when do you want to decommission the old part of the application. And then we finally keep applying this pattern until it makes sense and the monolith is completely gone. Likely, it's not going to be a one-on-one relationship between the bounded context and the deployable unit, but you get the idea, right? The goal is to get rid of the monolith as much as makes sense. Another example of this pattern that we see a lot actually lately is when a company is trying to modernize itself and they're going to start using a new platform. So we have a customer that had an old application running in a VM, and they wanted to go and migrate everything to Kubernetes. However, as we said, big bang refactor don't typically work. And what does not simply move a VM to K8s, right? It's not that trivial. There are other things that have to be done and handled. So what they did, they just added our product in this case was a Spring Cloud Gateway for Kubernetes on top, so they can modernize it over time. Slowly moving everything from the VM to K8s. It is the same pattern that we saw before, but now just moving things off the VM, off the platform to the new platform, right? So again, this is another way that you can modernize stuff, just having one gateway that's going to help us rerouting things over here to there. Okay, and next we're going to talk about a very common problem now as well, which is, it happens particularly on big organizations that are growing really fast. So imagine we have a bunch of services developed using different technologies, each of them secured differently. And this happens quite often, right? We have all the services that are developed by different teams, different levels, different options, different languages, different frameworks, but still we need to consume them, right? Now we are going to have a bunch of consumer of them. It could be a mobile phone, it could be different mobile apps, it could be a web, it could be another services that we want to consume them. This can be problematic. Right, the user experience as a consumer is far from great because we have each client having to consider different protocols, languages, sometimes writing different security flows. right? So a useful way to simplify this user experience is, unsurprisingly by now, I guess, putting a gateway on top. So this pattern is called the general purpose API, or backend for frontend, where the backend is the API exposed by the gateway, and the frontend could be anything, maybe a set of clients. Typically, or one of the ones I had done before is you have all the mobile phone version of an app will be talking to one of these backend for frontends or one of these gateway to simplify the client experience. So when we apply this pattern, we are collecting all the services and APIs into one neat API for our users to call. This API gateway is doing more than management, right? We are making changes in the request. We're combining information from multiple responses, right, from all the services. We're handling different protocols. We're using different security flows. But the good thing is that we can have one clean interface for all the external clients, right? We are moving all that complexity instead of the client to the gateway. And that can be very, very easily achieved with Spring Cloud Gateway by adding, for example, some custom filters where you can transform the incoming requests and responses and make that translatable to something the client will understand. And also all the security aspect, you can configure Spring Security in Spring Cloud Gateway. There's a really nice support, some things we have done also in the past. And it's very nice and an easier way to now make your gateway to be the authorization gateway, for example. Just everything using vanilla open source Spring Cloud Gateway and a lot of the Spring portfolio. And this is the great thing, right? By having a customizable API gateway that you can decide how much do you want to add on top of that. And next, Shruti.
All right. So lastly, let's get into what happens when when a service mesh gets added into the equation. The water can get quite murky here. So you might have heard a simplified explanation of the differences between a service mesh and gateways. We hear that service meshes are for east-west traffic in order to connect the services inside of your network to each other, and a gateway is for north-south traffic, making services internal in your network available externally to clients. But this kind of division is not quite that clean or straightforward, and we'll get into why. So a service mesh, what can it do? It allows you to establish service-to-service communication. That's the basics of it. It also allows security flows like user authentication, MTLS, service RBAC, observability, rate limiting, and many more. And there are some service meshes available in the market that also include a gateway implementation within them. So it can get quite difficult to differentiate what a service mesh can do and what a gateway can do, because as you can see, there's a lot of overlap in capabilities or topics of features between API gateways and service meshes. Hence, deciding where to put these responsibilities, whether you want to put this on a gateway or a service mesh, can be confusing. But the big difference between the two is what is the central character in a service mesh versus what is a central character for a gateway. A service mesh ultimately only caters to its connected services needs. It does that by providing metrics, security flows, load balancing, and error handling, and many, many more things to the services that are connected to them. So in simple words, if you look at a service mesh working in action, it would look like a lot of service meshes capabilities almost blend, but not quite actually blend into the service itself. In contrast, a gateway, an API gateway, wants to take all of these capabilities into a different abstraction layer, very distinctly away from all of the underlying services that it's connected to. An API gateway also tries to solve all of the common concerns between all of the underlying services while remaining decoupled from the underlying service. So due to this, an API gateway provides sort of this stable interface to the outside world, even when everything underneath it, the underlying services, are in constant flux. API gateways also have a very strong control over the traffic that is entering or leaving the cluster, thereby providing excellent edge or boundary level security. So getting back to our original question, when to use a gateway versus when to use a service mesh. The value of a service mesh really lies in the communication between services, whereas API gateway really shines in the communication between external clients and users and underlying services. Therefore, an API gateway is really needed for efficient external to internal communication. And honestly, the best place to start building your API, because it's natural to think about what are you trying to expose. In many cases, gateways might be all that you need, but if your architecture is grown and evolved to include a variety of different services and flavors of services that need a lot of internal communication, you might find benefits of adding service mesh to improve that service to service capabilities, if you are also okay with the added cost of it. So we went through a lot of different types of gateways and designs. So we wanted to summarize them in here. We went through these 5 different sections. And in particular, we laid out the overlap and the differences between gateways and service meshes. The role that your gateway, the API gateway that you are designing, can be either a subset or a superset of the above listed patterns. And if you're just starting out new or refactoring an existing gateway, we hope that we've given you some ideas to play around with. And as always, start simple, and you can add as many patterns as your need arises. And hopefully there are some design ideas for you to play around with. And if you have any questions about the content that we covered, or just want to know more about the team, you can always join the Q&A session and we'll be happy to answer them for you. Here are some interesting additional reads for you, which you can download when the presentation becomes available for you to download. And with that, we are ready to answer questions for you.
All right, thanks, Alberto and Shruti. That was amazing. Can't wait to dig in more of that a little bit later on. But for now, everybody who wants to follow on, go and continue talking about Gateway, go check out the Q&A session. We're going to take a short break, and when we come back, we're going to hear from Josh Long, Julian, I don't know how to say Julian's name. I'm going to guess Dubois, and Layla Porter, and they're going to talk about rapid application development with Azure Spring Cloud. So look forward to seeing that, and we'll see you after the break.